Hello friends, this question is for the test series number 4. Subject name is analog circuit, topic name is operation amplifier. It's a 2 marks problem. Question says that calculate the common mode gain of the amplifier, of the op-amp amplifier. Okay, so we know that common mode gain ACM is defined as V0 by VCM. Okay, keeping AD 0, where VCM is nothing but V1 plus V2 by 2, where V1 V2 is the input at inverting and non-inverting terminal. Right, so in this question you can see that if I may assume that the current across the resistor R2 I have a current I. Okay, so we know that the op-amp will be ideal, the input current of the op-amp is 0, so this entire I current is going to flow across R1. Right, so similarly the current in the input current of the op-amp is 0, so my R3 and R4 will be in series. I can assume it as a series. If I will assume is non-inverting terminal voltage as a V plus and the inverting terminal voltage as V minus, so what will be my V plus? My V plus will be nothing but R4 times R3 plus R4 of VI2. Right, well, because input current of the op-amp is 0, so R3 and R4 are in series, so I can apply voltage divider. But because it's a negative feedback, so my inverting terminal voltage must be going to equal to non-inverting terminal voltage, so this entire, so my this V plus will also going to equal to the V minus. Right, this is one thing we get. Now this current I which I have assumed across R2, so from the Ohm's law you know that current I is what? Current always flows from high potential to lower potential, in the direction of current is moving out from the V0, so I will be V0 minus V minus upon R2. Right, so you can have the relationship as, you can rewrite the equation as V0 is equal to basically V minus plus I of R2. Right, where I is nothing but, you can put the value of I is nothing but V0 minus I, and you can see that I is also the current across R1, because same current I is also flowing across R1, so you can write it down another expression for I, which is nothing but V minus minus VI1 upon R1, because same current I is flowing across R1 also, so just put the value of I here, so it will be V minus plus V minus minus V1 by R1 upon R2. Right, so just make some calculation and just separate the V minus and VI1 term. Okay, and you know that the relationship between V minus and VI2, that my VI2 is nothing but, my V minus is nothing but R4 upon R3 plus R4 times VI2, so let's put the value of VI1 here, V minus here, and separate the V1 and VI1 and VI2 term, and you will get the expression as minus R2 by R1 times VI1 plus 1 plus R2 by R1 upon 1 plus R3 by R4 times VI2. Right, and you know that because it's a op-amp, in the case of op-amp we know that what is my VCM, common mode voltage, will be VI1 plus VI2 by 2. Okay, and my differential gain VD will be VI2 minus VI1, because VI2 is the voltage in the non-inverting terminal, so differential gain is non-inverting voltage minus inverting voltage. So by combining these two equations you can get that simply my VI1 is basically equal to minus R2 by R1, VI1 is basically equal to, just put the value of VI1 here using these two equations, you can get minus R2 by R1 times VCM minus VID by 2, or VD, which I have assumed as a VD, VCM minus VD by 2 plus 1 plus R2 by R1 upon 1 plus R3 by R4 times VCM plus VD by 2. Right, just separate the term VCM and VD and you will get the expression as V0 is equal to 1 plus R2 by R1 upon 1 plus R3 by R4 minus R2 by R1 times VVCM plus half of 1 plus R2 by R1 upon 1 plus R3 by R4 plus R2 by R1 times VID, okay, or VD. So from this out we know that the output expression of the op-amp, is given as V0 is equal to ACM into VCM plus AD into VD, right? So in the expression we can know that the common mode gain ACM will be this much. So 1 plus R2 by R1 upon 1 plus R3 by R4 minus R2 by R1. This is the expression for common mode gain. So my common mode gain will be option number D. So number D will be the correct option, which is my answer, which will match the expression for me. So the idea is that we need to find out the expression for relationship between V0 to the VI1 and VI2, right? Use the virtual ground and all the properties of the op-amp, okay, and then use the relationship of the voltage relationship defined by in the case of differential voltage and common mode voltage, the CMRR property, and use them and get the answer. Okay, thank you.